All right, welcome back, guys, to Maths on African Motives. Still on our mathematics grade 10 revisions. This is a provisional examination that you're going to have, the June 2023 exam from the province of Gauteng. So just quickly rush through our questions so that we see how we're supposed to attempt these questions. So like I said, for mathematics paper 2, and we expected to answer this in an hour, and that was 50 marks. All right, so we shall see how we're supposed to attempt the questions. You're supposed to be very careful, read your instructions to understand every information that you are given here. So you are being given mostly that here you must answer all the questions and clearly show all calculations, diagrams, graphs, etc. were used in determining the answer. So whatever that you are going to be using, which were used, you are going to use them properly, clearly shown. And also you are supposed to have your answers to two decimal places unless they state otherwise on that question. All right. And also your answer will not only your answers only will not necessarily be awarded full marks. So meaning to say, guys, you are supposed to show the steps so that you obtain the full marks. And also your diagrams, they are not necessarily drawn to scale. So whenever you see your diagrams, it's just a diagram which is drawn. Do not take that to say you have to measure the sides on that diagram. Then you write those as your answers. No, it's not to scale. All right, so let us see, guys, what we have. This is the first question. Question number 1, having a total of 15 marks. So what are we given in this case? 1.1. If we are given the angle A, this is our part of trigonometry. So we are given the angle A, the angle B, determine the following. So take note here, we are not given how to round off our answers. So we use the one that we are given on the instructions. Remember, on our instructions, we are supposed to round off our answers to two decimal places unless we are told otherwise. All right, but in this case, we are not given anything, so we are going to use two decimal places. So we're given, in this case, A and B. So what you simply need, guys, is to substitute the angles that you are given. And take note, you are using your calculator in that case. All right, so what does it mean when we are writing the cos of A? What does it mean? It means you are multiplying 2 times A, which is A is the angle that you are given here. So we are going to have the cosine of 2A minus the sine of half B. In this case, the sine of half B, and a bracket like this is going to be cos of 2A, which is 2 times the angle A, or you can write it like this. You can just open a bracket, 2 times the angle A, which is 38.6 degrees, right? So this is our angle A. You substitute in A minus the sine of a half of B. So this is going to be half of B. Our angle B in this case is given as a 141.4 degrees. So this is what you're going to have. And with our simplification, we can simplify this, we can multiply this, or we can just use our calculator to obtain the answer because we've got 3 marks there. Or you can just combine this part here, you multiply 2 and this number. So you're going to have the cosine of, I'm just going to put the calculator there so that we can be together. So what you need on your simplification, like I said, you can combine this together, all right? Let me just remain with 1. So you're going to multiply 2 times 38.6. So that's 38.6 like this, which is going to give us, that's 77.2. So you're going to have 77.2 degrees minus half this sine of this. You're going to multiply half of this value, all right? So this is going to be sine half of this number, which is 141.4. If we divide it by 2, that means it's half of, you multiply that to 141.4. So this is going to give you 70.7. So that's 70.7 degrees. So on your simplification, instead of simplifying this you simplify this, you're just going to simplify everything at once now. So this is what you're going to have. You are just going to simplify direct the cosine of 77,2. So that's the cos of 77 like this, comma 2. All right, minus the sine of 70,7. So this is the sine of 70,7 like this. So what are we going to obtain? Obtain negative 0,7 to 2 like that. So to 2 decimal place, like I said, you can change this on your calculator. So this is going to be shift. You go to the setup. All right. So you're going to fix your values to 2 decimal place. You press this 6 here, and to 2 decimal places, you press this 2. So your answer is going to be given to 2 decimal places, which is negative 0,72. So that's negative 0,72 to 2 decimal places as the instruction of the question paper. So this is what you're supposed to have. If you do not understand this, guys, make sure that you watch the videos on the introduction of trigonometry. I talked about this on the introduction, so it can be best that you watch it for the simplification to be easier. All right, let us move on to the other part, which is 1.2. Calculate theta. Remember, theta represents the angle. So this theta is an angle that is between 0 to 90 degrees, meaning to say we are referring to our theta being an acute angle. And I talked about this, guys, on our introduction, that whenever you are finding this theta, you simply refer it to the reference angle whenever you talk about or you refer to the acute angle. This one is referred to as the reference angle. All right. So if it is the reference angle, that means we are just going to use the value that we get direct from the values that we are given here as our angles. All right. What am I trying to say? If we are given to solve the first one, we are given in this case, which is the sine of 2 theta. So 2 theta represents your angle in this case. So we are given that this is equal to 0,4. So what I'm simply saying is that to find the angle in this case, we were supposed to compare it in different quadrants because of what? Because sine or sine of a certain angle, we do not obtain one value for that angle that you are referring to as the decimal from the angle that you're going to get. But because it is an acute angle in your syllabus, because you work with acute angles, you're just going to take the reference angle as it is that you're going to obtain, which is the sine of, which is the 2 theta, the angle. Now we want to find the angle. Remember, guys, now we want to find the angle 2 theta. So you're going to have 2 theta is equal to remove this sign, to write it on the other side here, you are going to write it as arc sine. So this is arc sine of 0,4. All right, that is arc sine of 0,4, okay, which we simply obtain from our calculator. So that means the angle of 2 theta, remember we said that's an angle, this one. So we are saying the angle of 2 theta is equal to the angle that we get here. So arc sine gives us an angle. So this whole part here, it is now an angle, which we are going to obtain from our calculator. So like we are given, we are going to change this because this time we are given to round off to 1 decimal place. Remember us here, we changed our calculator before to 2 decimal place. So we have to change it so that it gives us our answer to 1 decimal place. So we're going to fix again, which is at 6. Then this time it's 1 because we want your answer to 1 decimal place. So you're going to press a 1. So meaning to say whatever that you're going to have on your calculator will be rounded to 1 decimal place. All right, so let's find arc sine, which is shift sine. This arc sine, this one, it's on this side. So it's shift sine 0,4. All right, so what are you going to obtain in this case? That's the angle. So like I said, your calculator is already rounding off your answers to 1 decimal place. So this is going to be 23,6. All right, so we are going to have 23,6 degrees, which is the angle, because we are talking about an angle to an angle. We can find the value of theta if we divide by 2. Since this is a multiplication, so we can divide by 2 That's we have got the value of theta. So what is going to be the value of theta? Theta is going to be the answer that you obtain if we divide this by 2. So the answer that we have, simply divide it by 2 to 1 decimal place. It is going to be 11,8 degrees. All right, so that is how we could have used our calculator to simplify our values and so forth. So you just have to be careful in your simplification. How do you work out these typical questions? All right, so we have got a same scenario in this case on question 3. I'm just going to utilize this space. I think I'm just going to be able to write everything here clearly. So this now is 3, the sine of theta over 2 like this, minus 20 degrees, which is equal to 0.85. Be careful when you have a question like this. All right, the first thing is this number 3, it is multiplying a trig of sine. It is multiplying the sine. It does not mean this is an angle. It is just a number that is multiplying. This whole part that we see here is the one that is representing our angle in that case. So what can we do? We can get rid of this 3 that is multiplying. How do you remove something that is multiplying? We have to divide by it both sides. You're going to divide by 3 here. You divide by 3 this side. So that means this will cancel. You remain with the sine of theta. So this is going to be the sine of theta over 2 minus the angle of 20 degrees. But like I said, this whole part as it is, this section here, it represents the angle. That's your angle in that case, all right? So like I said, it represents our angle. So this must be equal to whatever that you're gonna have. Maybe you're gonna have it as a decimal, or you're just gonna leave it like that, which is still fine, because we are not going to use this value like as our answer. We need the one that we're going to obtain when we put sine on this side, all right? So remember what I said. In order for you to obtain the angle now from the sine of that angle, in order to remain with the angle here, only to remove this sine, to write it on the other side, it is going to be arcsine of the value that we have on the other side. So that means here we are going to remain with the angle of theta over 2 minus 20 degrees, which is equal to, you take the sine to this side, but you do not just write it as a sine. Once you write it on the other side, it is going to be written as arcsine. There's going to be a negative on top, which is arcsine of 0.85 over 3. So that's, you are now having an angle here. Whatever that you're going to get here, it represents the angle that is equal to this angle that we have, that we talked about before. So this on the other side here, it represents what? It represents the angle as it is. That's your angle. So meaning to say, I'm going to simplify this theta over 2 minus 20 degrees is equal to the angle now, which is the same as this angle that I'm having here. So which is arcsine of the value. So I just need a calculator. And like I said, our calculator is already to 1 decimal place. Remember, we already fixed our calculator to 1 decimal place. So we're just going to use it as it is. That is shift sign, that is arcsine. This one, it must show a negative there. All right, so you put 0.85 over 3. All right, so this is over 3, which is going to give us 16.5. So like I said, this now, it is indicating, or it is representing an angle. You're now referring to an angle. So that means this is 16.5 degrees, because you are now having an angle on this side. So what are we going to do with this part so that we obtain theta? Because the question is, we are supposed to solve for theta, all right? We are supposed to solve for theta. How are we going to solve for this theta from this stage that we are having? All right, since these are the same, because we are now referring to an angle, we can transpose negative 20 to this side so that it becomes a positive. So what it means is that I'm going to remain with theta over 2. So theta over 2 is going to be equal to, if I transpose negative 20 to the other side, it becomes a what? A positive. Negative 20 here, it becomes a positive. So I'm simply going to add 20 on this value. So this is going to give us 36,5. So that's 36,5 degrees. So how do I obtain theta at this stage? This one is same as it's written like over 1 like this, so that you can cross multiply. Here you multiply 1 times theta. Here you multiply 2 times this value. So that is how you do your cross multiplication. 1 times theta, which is theta, is equal to 2 times this value. So you simply multiply the answer that you have of 36,5. You multiply it by 2 like this. You are going to obtain 72,9. So that's 72,9 degrees. So this is the angle that you are going to have representing theta. All right. At this stage, we could have calculated this way from this stage. Maybe we've got theta over 2, which is equal to 36,5 degrees. I can just ask myself, how can I remove this 2 this side? I can multiply by 2 here. I can multiply by 2 to remove these 2 so that I remain with what? Theta. So theta is going to be the product of these 2, which is still the same thing, 72,9 degrees. So as you can see on your calculation, as long as you are working with an equation, you can simplify it the way that you understand, as long you are working with an equation, because this one is now an equation. You are now solving for theta. To find the value of the unknown is to solve. All right, so that was our question 1.22 in this case. Let us check 1.3, where we are given again on a trig, but this time you are given not to use a calculator. All right, calculate the following without the use of a calculator. So what are we going to do? We are back now to our special angles. All right, so like I said, guys, everything I talked about this on our introduction. So make sure that you watch the videos on the introduction so that you'll be able to understand whatever that we are going to explain here. So this is sine squared of 45. Remember, I said when there's a squared like this, it means it is sine 45 degrees. The whole of it is being raised to the exponent of 2. All right, minus the cos of 60 degrees. So this is minus the cos of 60 degrees. So whatever that you're going to have here, what is it that what is going to be the equivalent? That is the question. All right, like I said, this is a simplification that you have on your special angles. And I also explained previously that yes, you are told not to use a calculator, but on a condition that you are actually limited. Use your calculator to find these values, because the values that you obtain from your special angles are the ones that you obtain direct as the one that you obtain on your calculator. So no one is going to know that you have used what? A calculator to find or to state those values. But in actual sense, you are supposed to use what? Your special angles. Remember, from the triangle of 45, this is 1, 1. This is the square root of 2. Also, we have a condition of 60 degrees on this side, 30 degrees on this side, where this is 1, this is 2, and this is square root of 3. Remember, I said you can find any ratio which is the same as what you have on your calculator. Whatever ratio that you have here will be the same as what you have on the calculator. So the question is, what is going to be the ratio of 45 degrees sine 45? So according to the 45 degrees, we know that our ratio is supposed to be opposite. All right, let us write our SOHCAHTOA concept. So back to our mnemonics, that is SOHCAHTOA like this. All right, which is the sine is opposite over the hypotenuse. So according to this angle here, depending to this angle, this is going to be our opposite. It faces the angle. This is our adjacent, and this is our hypotenuse in that case. So that means I can use the value that I get here direct as it is, which is 1 over the square root of 2. This is the sine of what? Of 45 degrees. 1 over the square root of 2, or I can write it in the simplest form, if I remove this side by multiplying by the square root of 2 over 2. But if you take it from the calculator now, you are going to see it, the calculator, it gives you a simplified value, which is the square root of 2 over 2. That is the difference that you are going to have with you who took it from the special angles. You take as it is 1 over the square root of 2, unless you want to change it to the way that you want, but you can just leave it like that. So this is 1 over the square root of 2, everything being raised to the exponent of 2, all right? Minus the cos of 60 degrees. Now we are working according to the 60 degrees here. All right. Remember the ratio of cos is given here as the adjacent over the hypotenuse. So that means the cos according to the 60 degrees, this is your opposite. This is your adjacent, just like this part. This is the hypotenuse because we are still talking about this angle at the same point, like at this end here. So from our formula, adjacent over the hypotenuse, the adjacent there, that's a 1. So this is going to be our adjacent, which is a 1 over the hypotenuse in this case, which is our hypotenuse is a 2. So this is what you're supposed to have in an actual sense. So the question is, how can we simplify this further? So like I said, once you write this stage, you can even use your calculator. If you are now stuck at that point, you can use your calculator to simplify this stage, all right? But if you work it directly, 1 over the square root of 2 squared means we've got 1 squared, which is 1, all right? That is 1 to the exponent of 2, which is 1 over the square root of 2 to the exponent of 2. Remember, guys, the square root of 2, once it's raised to the exponent of 2, it gives us the number under the square root. You simply remove the square root, or remember from your sets, the square root of a times the square root of a, which is the square root of 2, times the square root of 2 is going to give us a 2 if you're multiplying two numbers that are the same under the square root. So meaning to say, this is going to give us 1 over 2. But like I said, guys, your calculator is there. When they say do not use a calculator, they are saying do not just simplify direct what you see on that expression on your calculator, but you can actually use a calculator to simplify some certain stages, all right? Like this stage, you can just use our calculator here, open the bracket, 1 over the square root of 2. So this is the square root of 2, then close that bracket, you raise to the exponent of 2, you obtain 1 over 2. So that means here you are going to have 1 over 2, just like the same way we obtained here, all right? Same answer, I mean, all right, over 1 over 2 like that. So we are going to subtract 1 over 2 minus 1 over 2. Guys, if you're subtracting same numbers, it means you're going to get a 0. Or you can just use a calculator, minus 1 over minus 1 over 2 like this, which is going to give us a 0. So that is how we could have simplified our question in this case on 1.31. And that is all right, many marks, 3 marks for that, which is actually fine. All right, let's check 1.32 again. Like I said, once you're given not to use a calculator, you're back to the application of your what? Of your special angle. So it's sine 30 degrees to the exponent of tan 45. Let's see what does it mean. All right, let's go back here to our special angles and write this down so that we can properly see. All right, so that's 1.31, 1.32 now. All right, so 1.32. So this is given as the sine of 30 degrees. All right, so that is the sine of 30 degrees, right? Everything being raised to the exponent of tan 45 degrees like that. Do not be scared when you see this simplification or this way. Don't be afraid of this. Just substitute your values properly, all right? We are now referring to the 30 degrees on this triangle, not 60 degrees. So according to 30 degrees, this is our 30 degrees here. It means these sides, they are going to change. We are no longer having this as the adjacent. No, it is going to change. We are no longer having this as the opposite unless for the hypotenuse, it is the one that is not going to change. So according to the angle that you are given, according to the angle that you are given, it determines the sides. So according to 30 degrees, it is going to be opposite. This side is going to be opposite to 30 degrees, and this side is going to be adjacent. All right. So that is, you name your sides according to the angle. So the sine of 30 from opposite over the hypotenuse, we're going to have the opposite, which is 1. All right. So that is opposite over the hypotenuse in this case, which is what? Which is 2. Everything must be raised to the exponent of tan 45 degrees. So that's tan 45, and tan is opposite over the adjacent part. 45, we are back on this triangle. Use what we have on this triangle here. The tan of 45 degrees from the opposite over the adjacent. According to this, our opposite is 1 over the adjacent, which is 1. So 1 over 1, which gives us what? Which gives us a 1. So it means you are having 1 over 2 to the exponent of 1. So as you can see, guys, they just wanted to scare us with this tan, sine, whatever that you are given. So like I said, don't be scared when you see this simplification. And here you can obtain 1 over 2 at the end. Remember, every number that you have to the exponent of 1 is that number as it is. It remains as it is. So 1 over 2 to the exponent of 1 is same as 1 over 2. It is not going to change. All right. So that was our question on 1.3. All right. Actually, 1.3, it was the simplification part only. That is what we had without using a calculator. All right. Then we've got question number 2. If we check on question number 2, there's another part which is not part of the diagram. This one that you see, it's not part of the question, not of the diagram, this part. All right, something that I just put so that we can be able to answer our question, because we need this part here. All right, so then we are given to draw a neat sketch. So we're going to draw neat sketch graphs of f of x being equal to negative sine x, the g of x being equal to half cos x, where x is an element taken from 0 to 360 degrees. All right, so these are the functions that we have. So like I said, this is not part of our question, right? So it's something that I just gonna use to answer this question. All right, so take note, guys. Here we are given 2 functions that we need to draw or to sketch the graphs of f of x equal to negative sine x. So I'm just gonna have my 2 functions here so that we can explain about these 2 functions. All right, maybe if I put it or even aside here, it cannot be fine. All right, let me just put it a little bit like this. All right, so that you can properly see. So we've got 2 functions that you're going to consider: the f of x, which is equal to negative sine x, and another graph of gx, which is equal to half cos of x. These are the 2 graphs that we are given. In this case, our curves here, f of x, negative sine x, the g of x being half cos x. So the question is, in the interval from 0 to 360, how can we draw these graphs? Remember, guys, what I said about the 2 graphs of cos and sine, that these graphs that we see here, they can be drawn direct. We can draw these graphs direct by having the same step there. Like I told you, you are going to have the same step of this graph. They are going to be separated by 90 degrees from each other. It's only the graph of tan of theta or tan of x which uses a separation of 45 degrees. All right, so from our previous part, or from our introduction, I introduced you guys to a condition where you are supposed to draw a table so that it can associate with the values from 0 to 360 degrees. It can have the values from 0 to 360 degrees, which is your interval. So we are going to draw a table, and I also told you that we are going to have another method of using our calculator direct so that we can have our values of x. I'm going to show you also that in this revision so that at least you can either choose that way or you can maintain to the one that you understand that we had on our introduction of using the table direct like this. So this time it's not y is equal to sine theta or what. We are using f of x is equal, which means y is equal to negative sine x. So it's x, not theta. So meaning to say here, we do not have theta, we have x, all right? So we are going to have x, and here on the y values, we can write it as f of x, or you can write it as y. It's up to you. Or you can just write it as what? As f of x, which are the y values, all right? So f of x represents what? The y values. And like I said, if you're drawing the graph of sine and cos, you separate these ones by 90 degrees apart. So you're gonna have 0, 90 separated apart. So that's 0 degrees, 90 degrees, 180 degrees, 270 degrees, 360 degrees. That is going to be your separation of angles when you are dealing or when you are working with the angle of what? When you are working with the graph of a sine or the graph of a cos. So it is the same situation that you were going to also have on the graph of gx, which is equal to the half of cos x. You are still going to have the same table, just like the previous case, where you are going to have your x and y values, which represents the g of x. We've got x and we've got y values, which are represented by what? By gx. And our separation for cos and for sine is the same. So our angles are going to be the same, or they are going to be taken the same. That's 0 degrees, 90 degrees, you move on to 180 degrees, 270 degrees, you move on to 360 degrees. The way that you separate your angles is the same way that you do on these graphs of cos and what? And sine, which is different only for the graph of a tan. So like I said, you are supposed to go back to your calculator, find your values, direct each and every part that you are given on your calculator. You are going back to the negative sine of x. So it's going to be negative sine of x. Our first angle there, that's S0. All right. So make sure that your calculator, you bring back to the normal mode. So if you still have that fix, if your calculator shows that fix here, you're supposed to go back to shift, set up, you go to the normal at 8, then you press 2, it goes back to the normal mode in case that your calculator is still showing the fix, because we were using that to round off our answers, but here it's no longer there. So it does not affect my answers, all right? So that's 0 in that case. I move on to 90 degrees. I do the same up to the last part of the angles, which I'm given -1 and so on. So this was going to give us a 0. This was going to give us a 1. This was going to give us a 0. You do the same thing on half or cos of x, all right? That is, this time we are going to have half of cos. So this is half cos, all right, of x. So the first angle representing x there is 0 degrees, all right? So that is, we are going to obtain a 1/2, which is same as 0.5. So I'm just going to use a decimal, which is easier to work with on our graph. So that's 0.5 in this case. At 90 degrees, to do the same thing, you substitute here 90. So that is going to be at 0. You do the same thing at 180 degrees. You substitute your value here, which is now 180. You obtain -1/2, which is same. If you convert to a decimal, that is same as -0.5, and so on and so on. So that gives us 0.5, as 0 here, 1/2, which is same as 0.5. So this is what we were supposed to have. All right, but like I said, we have a condition, guys, because here I'm going to take this table. I mark my points back on the graph. I do the same for gx. I mark my points on the graph. But what if I wanted to use the table at once? All right, this is how we can simply, I'm going back, guys, here. We're going to use this table, don't worry. I'm just going to show you how you can use your calculator at once to obtain the two tables that we see using the calculator. Using the calculator to determine the values, all right, to determine the y values. So these are going to be the y values. I don't know what this machine wants to open now. All right, the y values, or we are simply to draw a table. All right. So the table that you're gonna have can be taken from your calculator direct. So this is what you're gonna need on your calculator. Now, just afraid like to show the screen here because it's like this machine, it wants to open something and I don't know what is it that it's supposed to open here. All right, no problem. So this is what is gonna happen on your calculator here. You are going to this mode, all right? What you're going to do, you go back to this mode, all right? On this mode, there are two modes. There are many modes that you can have. The compact, whatever that you have, there are so many. So as we need to draw a table, so you're going to go to the table mode, which is the 7, this one, all right? So you press 7, which gives you f of x. So these are the functions that you are given, your f of x and your gx, all right? So I want you to see what I'm trying to say. You have your f of x here, and you have your gx. This is your f of x. This is your gx. So you can write these functions on your calculator. F of x is negative sine x. All right, so I want you to see how you're going to write this on your calculator. So this is going to be negative sine, all right? So to obtain x, this x, you can write it on your calculator. If you press this alpha, then you go to this x in this bracket. So this is alpha, you go to this x like this. So this is your f of x, all right? You press equal to, it gives you gx, which is if you have another function, you have to press it. But if you do not have, it's fine. You just work with one function. But here we also have gx, and gx is a half cos x. So it's going to be 1 over 2 cos of x, which is cos our x. We're going to do the same thing. Alpha, we press x here, close the bracket. All right. So there it is going to give you start. When it is representing start, it is saying where is it that your graph is going to be starting from. From your table here, you are starting at 0 degrees, which is the same thing as what we are having from our graph, or from the interval that we are given, that x is greater or equal to 0 degrees, less or equal to 360. So we are starting here. This is our start point, and this is our end point. So our start there is going to be a 0, all right? So there, we are just going to present it as a 0 there. That's we are starting at 0. You press equal to. We end at where? At 360 degrees. All right. This step, this one, is how you are separating your angles. 90, 90, 90. You're separating this by the angle of what? Of 90 degrees. So that is going to be like this. So as you can see on your calculator, it gives you corresponding values. This is x, this is f of x, this is gx. So it gives you in form of a table in that way, all right? So I want you to see so that if you maybe in future case you want to use that, but you can just use straightforward, all right? As you can see your calculator, it gives you x, f of x like this. So it's already giving you all the values for x. All right, straightforward as it is 0, 90, 180. These are the x values, as you can see, up to 360. So we are given 0 and so on. That's 0 like this, like this. All right, that's 0, 90, 180, 270, up to 360. It also gives you the values corresponding to f of x. If you check for each value, go back on top here at 0. We are having a 0 there on f of x, all right? Minus 1 is 0, and so on. This one, 180, it's a 0 there. Go down to 270, which is a 1. 360, which is a 0, so that's 1 and a 0. The same thing on gx. If we check, go back on top, that's at 0 there. It's 0, 0.5, 0 minus 0, 0.5. So having 0, 0.5, 0 minus 0, 0.5, and so on up to the last term. That's here. It's gonna be minus 0, 0.5, 0, 0, 0.5. All right, so that's 0, 0, 0.5. So if you check, it is the same thing as what we are having here, but we need to know exactly here. You can just use your calculator. You are the one who is manually representing on your calculator. This is the difference that we have between the two. The calculator can give us exact values at once, or it is us who can put these values one by one on our calculator. So you choose the method, guys, but with both methods, what it simply represents here is that your x values here, they correspond to f of x, which is the y values, same as for gx. These are the same as what we have on this table that we see. So what we simply need, guys, is to mark our points on the graph so that we can, on our Cartesian plan, so that we can be able to draw our graph. All right, so let us try to mark our points. I'm going to start with the graph of f of x, all right? So I'm starting with f of x. So f of x is 0 versus 0. Remember, I talked about this on our introduction, that whenever y is equal to 0 or f of x is equal to 0, it's what you represent in the x-axis, which is in the horizontal axis. That's where you put a point. So if we are given 0 versus 0, it's a point that is at 0 on the horizontal axis at this point, all right? 90 versus minus 1. This is 90 degrees minus 1, which is at this point. So I mark at -1. All right, 180 versus 0. We are on the horizontal axis. So we mark at 180, but on the horizontal axis, that is on the x-axis. All right, 270 versus +1. That is 270 here versus +1, which is on top there. So 270 versus +1 on top. Then 360 versus a 0. 0 always in the horizontal axis, in the x-axis at 360 degrees. I mark my point there. So this is what I'm going to have. I'm simply going to join my graph that is from this point here. I'm going to have my graph joined, or let me just try to reduce. Maybe it's gonna be easier to join this part. So this is our point from this point to this point at -1. All right, to that point like this. All right, then you go back to this point. This is a little bit, let me just try join back a little bit like this. All right, so this is how we were supposed to have our graph. So that is the graph in this case of f of x. So this is our f of x, or you can write y is equal to minus sine x. So it is the same thing that you could have done here, working with your x and f of x. In the first place, when you are done, you work with x and gx. So now we are going to see the same thing, working with x with the gx, which are the y values. So we're going to mark our points. That's 0 versus 0, 0.5. That's 0 here versus 0, 0.5 is this one on top. So you mark at 0, 0.5. All right. 90 versus 0. Remember I said always 0 is in the x-axis. So 90, we're going to mark at 90, but at in the x-axis, that is at what? At 0. All right. 180 versus minus 0, 0.5. 180 degrees is here, minus 0, 0.5 is here. So where these two meet, you mark a point. 270 versus 0, we are back to the x-axis at 270. 360 versus 0, 0.5. 360 versus 0, 0.5, we are at this point, straight to 0, 0.5. So these are the points that we were supposed to actually join. So how are we going to join these points, all right? So remember, the graph, of course, is something like this, Okay, so also you must know the shape so that when you are drawing this graph, you are of the idea of how your graph is supposed to be like. All right, so our graph for cos is supposed to be like this. All right, so you're gonna join up to the minimum point at negative 0.5. It goes to the 0, here at 270, then to 0.5. All right, it's supposed to be a little bit less, up to 0.5 like this. So now it's because it's now a stretched graph. This graph is now a little bit stretched, but the graph of supposed to be something of this nature. Remember your graph, of course, guys. All right. So that is our gx in this case. All right. So this is our gx with graph of g, which is half cos x. Right. Let us just write, maybe for the sake of revision, half cos of x, and our f of x is the one for negative sine x. So as you can see, the normal graph of sine x, it was supposed to be like this. So the negative here is the one that made us to see our graph now in the other way. It's a reflection that happened in the x-axis when multiplied by what? When multiplied by a what? A negative like that. So that is how you are supposed to have these graphs. You can draw these graphs from the table in whatever way that you understand, as long as you understand what you are doing, or you can do this way from the table like I explained. Those steps using your calculator, you can use that step by step. You obtain your table, and after that you mark your points, you draw your graphs. All right, so let us see the other part of the question that we are given this time. They are saying, now on 2.2, determine the amplitude of f of x. All right, that is 2 marks for that. Remember, the amplitude is simply the difference, half of the difference between the maximum and the minimum value. All right, so that's 2.2. We know that the amplitude is simply the difference that we have, half of the difference that we have between the maximum minus the minimum value. So there we are told the amplitude of f of x. So we are referring to the graph of f of x. So on the graph of f of x, this is our graph of f of x. Remember, our f is this one. So our f is like this. This is your f. So the maximum value that we can ever get at f is this value that is corresponding here at point what? At 1. That is the maximum value that this graph can have, which is at positive 1 in the y value. Take the y value there, which is a positive 1. So it's going to be half of the maximum value, which is 1. So the minimum value, this graph can go down, but it cannot go down to -2 or -3. It can only reach -1, which is our minimum value. The y value there is -1. So there's a negative for the formula, this one. Then the minimum value is carrying a negative. So you must write a negative and a negative. The negative, this one, like I said, is for the formula of the amplitude. This is the formula. But the number that you are substituting is carrying a negative. So you must use that as a negative to a negative. And remember, a negative to a negative, it gives us a positive. So that is going to be a positive in this case. Negative, negative. So 1 plus 1, which is a 2. And we've got half of 2, which is half of times 2, which is a 1. So the amplitude in this case was going to be a 1. So this is how our graphs can be answered. So this part, guys, I also explained. Make sure that you watch the videos on the introduction of this trigonometry. All right, 2.3, what is the period of gx? What is the period of gx? Remember the period, we are now talking about like how many in how many times, like in a certain interval of a certain angle, like from 0 to 360 or maybe 0 to 180, where a graph is going to repeat itself, like cycles that we have, complete cycles, that where the graph to complete a graph to complete itself like this. It's a complete cycle for sine like this. Another cycle starts here like this. It's a complete cycle again like this. I explained this on the introduction also. Another cycle like this. So that is the period to say when the graph is repeating itself. When is it repeating itself? So here we need the period of what? Of a gx. Gx is the graph of course, this one. This is our gx, this one. So if we check the graph of course, it repeats itself after every 360 degrees, right? I talked about this, guys, on the introduction. At this point, it will be at 360 degrees. We'll see another shape imagining from this point of 360 to 720 degrees, the same shape that we see like this, that we have from 0 to 360, from 360 to 720 degrees. So it means it is repeating itself in each and every 360 degrees. That is our period, all right? So in this case, our period is just 360 degrees, all right? But the moment you see the graph of cos and the graph of sine, all right, they have the same period, all right, 360 degrees. Then for tan, the period is what? 180 degrees. You can actually understand it that way. All right, then on this question, it was actually an error with the marks that you are given here. This is actually an error because they are saying for which values is minus sine of x minus cos of x is equal to 1. The difference where these two gives us a 1. All right, it's actually an error. They wanted to take this graph as it is minus sine x, and here they wanted to take half cos of x like this. It was supposed to be half cos of x. Where do we have the difference of these two graphs giving us a 1? So it was just a typing error, this and that. All right. The moment you have it as a minus cos, it means we are supposed to redraw the graph of cos. And with the 1 mark that we have, that, remember, just to draw this one graph, just to draw one graph, 6 marks, it's 3 marks. And 1 mark to answer a question so it was just an error there that happened. So what are they trying to say? Let me explain this way. Here they are saying minus sine of x. All right, let me write it this way. Minus sine of x minus half cos of x. This was supposed to be the question. Minus cos of x is equal to 1. All right. If you get rid of this, you are going to see that wherever you are given minus sine of x, this one, minus sine of x, it represents f of x. So here they are simply saying, where is it that your f of x, when you subtract, wherever you see half cos x like this, wherever we see this half cos x, we are seeing what? We are seeing gx in that case. So where is it that f of x minus gx, it is supposed to give you a 1. So I referred to this on our introduction and said, this one, it's a distance. They simply want you to give a point or a value of x where the difference between these two functions is a 1. But f is supposed to be the one subtracting gx. So where is it that our values of f, here, these are the values for f. When you're talking about the values of f, we are talking about the values of y, that is at 0, at -1, at 0, at +1, at 0. Where is it that you take a value on f, then you subtract it to the corresponding value of y, which is of g in this case, because we are saying f of x minus gx. Where is it that you subtract f and g, then you get a 1. So it's a trial and error where you have to check, but by just checking here, there's no way that we can take our values from 0 because it's already in the negative. Your f of x is in the negative, and if you go to the point at 180, the difference between this f of x minus gx, there's a difference there of 0.5, right? This is minus 0.5, not 1. All right. If we move to 270, f of x is at 1. Our gx is at 0. So if we subtract the difference between these 2 points, it's a 1. That's 1 minus 0 is a 1. So at 270 degrees, the difference between the two functions is a 1. So it happens at x is equal to 270 degrees. At 360 degrees, it's no longer that because f of x is now down. It's now it's like 0 minus 0.5, which gives us minus 0.5. So it's no longer giving us a 1. So you have to check on your graph, where is it that you have a difference of 1, but it must be f of x being the one subtracting gx, not to say gx minus f of x. No, it's f of x minus gx. That is our question. So guys, be careful how you are given these typical questions, meaning to say, if they wanted the value of x, so this one, it was at what? At 270. If the question wanted us to find a condition this time, if they wanted you to find a condition where gx minus f of x is equal to a 1, what does it mean? It means you are now subtracting. G is the one that is supposed to subtract f of x. So this one at 270, it won't be able to work because at 270 degrees, G is the one that is at 0. So if you subtract 0 minus f of x, yes, it is the one that is at what? At 1. But if we subtract this, we get minus 1, not a positive 1. So where is it that G, when it subtracts f, we get a difference of 1? We must consider where G is at least on top. And here, if we consider here, there's a difference of 1 if we check. This is our G. Remember, the G is the one that is in blue, this one. This is our G. So G at this point, it corresponds in the x-axis where I said y there is equal to 0. So this one is going to be 0 minus f of x. Our f of x at 90 degrees is at minus 1. So it is going to be 0 minus 1 like this. So that's going to be 0 plus 1, which is a 1. So meaning to say, where gx subtracts f of x to give us a 1, it is at 90 degrees. All right. I'm saying if the question was not to say this one that we answered here, guys, for this one that we answered here, we said our angle is at what? At x is equal to 270 degrees. But if it was another condition, that is how you're supposed to answer your question. All right, so that is how you play around with your table. Guys, you need to understand this information. You need to understand your trigonometry. Make sure that you watch the introduction. It helps you to work on each and every section. Is it drawing of these graphs? Is it finding equation of a trig graph? Is it simplifying trigonometric expressions with a calculator and without a calculator? Is it solving of trigonometric equations? All that is there on the introduction. So just go to the playlist of the trigonometry, watch your videos there as much as you want. All right, question number 3, we are given, study the diagram below and answer the questions that follow. So this is the diagram that we are going to work with. And there on this diagram, I've got the point A, the point B, and the point C. That is, in this case, this is 1 minus 1 minus 5, like this, 1 minus 5. All right, this is 3, 9. I hope this one is clear. This is 3, 9. This is negative 5, 3, right, this point, so that it can be clear at least. All right, so the question here was 3.1, calculate the coordinates of the midpoint of the line segment AB. All right, of the line segment AB, this one, we need the midpoint. All right, so the midpoint, remember, it is represented by the letter M, but you're just gonna use the capital letter M for the midpoint and the small letter m for the gradient. All right, so this is the midpoint of the line AB. All right, remember guys how you determine the midpoint. From the midpoint formula, you add the x values together, x1 plus x2 over 2. You add the y values together, you divide by 2. All right, it is a point at the mid in between A and B. So in between, you add your x values together, you divide them by 2. You add your y values together, you divide them by 2. That is how you calculate the midpoint. So meaning to say, we were going to have the midpoint of the line AB as the x values. So it's going to depend how you want to write your values. Maybe you want to put this as your x, as your first point, which is going to be x1, and this will be our y1, this will be x2, this will be our y2, or guys, you can just sub as long you are working with the x properly, right? So if you want that way, we're going to add our x values. That we've got a 1 on this side, and here we've got a 3, or you can just add 3 plus 1. That's what I'm saying, all right? So this is going to be 3 plus 1 over 2. The y values, you do the same, 9 and negative 5. So it's going to be 9 plus negative 5 like this, everything over 2, all right? So here, do not waste your time. Just use your calculator to simplify the midpoint of this. So this is going to be a point, all right? Remember, the midpoint is simply a point in that case, all right? So let us see what you're going to have. So you have to change our calculator again to the normal mode. So this is, you go to the compact, which is 1, all right? So there, the first for x, this one, you just simplify as it is on your calculator. So put a fraction, 3 plus 1 over 2 like this. So this is going to give you a 2. You separate it. You go to the y values. We've got 9 and minus 5. So this is 9 plus minus 5 like this, everything over 2. So that is going to give you a positive 2. So this is the midpoint of AB. So somewhere there, there's a point that is in between, between these 2 points, that is referred to as AB. That is referred to as the midpoint, and its value being 2, which is just in between the point A and the point B, that is being a midpoint. All right, then let us see the other part. They are saying 3.2, calculate the gradient of the line. 3.21, the gradient of AC. All right, the gradient of AC. All right, so there we have our A and C. We can calculate the gradient. Remember, like I said, for the gradient, we can use the small letter. Remember, the gradient, guys, is the change in y over the change in x. So the gradient of AC is simply, you can write it as y2 minus y1 over x2 minus x1. So this is y2 minus y1 over x2 minus x1. It's up to you. You can use y1 minus y2, guys, as long you are properly subtracting your values. If I'm talking about AC, this is where I'm having AC. I can use this as my first point and this as my second point. So when I'm saying y2, I'm talking about the y value at the second point, which is 3 minus y1, that is the y value at the first point, which is 9 over x2, that is the x value at the second point, which is minus 5, minus x1, that is the x value at the first point, which is 3. So I can just use as it is like this. I'm going to obtain an exact answer for this gradient. All right, so on our calculator, let us quickly have this. All right, okay, let us quickly have this, guys. 3 minus, okay, let me put a fraction first. It's going to be easier that way. 3 minus 9, okay, over negative 5, negative 5. So this is minus 5 minus 3, not minus 5, but minus 5 minus 3. So this is going to give us a positive 3 over 4. So that's a positive 3 over 4. So this is the gradient of the line AC. All right, let us move on to the other question, which is the gradient of CB. We are still on the gradient of the line. Okay, we calculated for AC, now for CB. So these were just 2 marks, all right? So let us calculate for CB in this case. So the gradient, like I said, the gradient is just gonna use the small letter, all right? So the gradient of CB is gonna be the same way, just like what we calculated here using the formula. The change in Y over the change in X is gonna be Y2 minus Y1, which is the same thing, guys. Y2 minus Y1 over X2 minus x1. All right, so that means according to C and B, this is our CB, this one here. We're talking about CB. So it simply means this I'm not going to have as 1 and 2. This one is another condition now. So according to CB, I can take this as my 1 and this as my second point. All right, that means y2, that is the value of y at the second point, which is negative 5 minus y1, which is the value of y at the first point, which is 3, over x2, which is the x value at the second point, which is 1, minus the x value at the first point, which is x1. So that's a minus 5, this one. All right. So that's going to be a negative 5 like that. So this is going to give us the gradient of CB in that case. All right. So here, like I said, guys, it's you and your calculator. Use your calculator properly. So put a fraction here, negative 5 minus 3 like this, okay, over, this is 1 minus, it's a plus. So it's 1 plus 5 like this, which is going to be negative 4 over 3. Negative 4 over 3 like that. Okay, so that is the condition. So the question is now, remember how you're supposed to simplify, guys. Show that AC is perpendicular to CB. All right, the line AC, which is this one, the line AC is perpendicular to the line CB. So they are saying show that there's a 90 degrees, it's perpendicular. These two lines, they are perpendicular. How do you show that the lines are perpendicular? All right, we have got a condition that you use when we are showing that the lines are perpendicular, all right, that is 3.3. So to show that the lines are perpendicular, you need the product of their gradients. So if I multiply the product of gradient, the gradient of AC to the gradient of CB in that case, let me see what am I going to have. If they are perpendicular, our answer is supposed to be a negative 1, but here you are showing, you are proving. So you are supposed to do it step by step. You substitute your value, 3 over 4 times for CB, which is minus 4 over 3. So by doing this, guys, we're going to see that our answer was going to be a negative 1. So if you multiply this direct on your calculator, you're going to get a negative 1. So this negative 4 over 3 times 3 over 4. So if you multiply to 3 over 4, which is the other value, get a negative 1. So that means these two lines, they are perpendicular. So therefore, we can conclude that they are perpendicular since we know that perpendicular lines, the product of their gradients is a negative 1. So therefore, the line AC in that case is perpendicular. So it is perpendicular to CB in that case. All right. The reason is because the product of the given gradient is negative 1. All right. Since the product of gradient, all right, since the product is negative 1. All right. We know that the product of gradients should give us a negative 1 for perpendicular lines. All right. If the lines are parallel to each other, they have the same gradient. But for being perpendicular, the product must be a negative 1. So that is what we're supposed to have on this part. Then the other part, 3.4, now they want the length of this and that, the length of AC, this and that. All right, so the length of AC, we can simply have it. I don't think we're gonna need this gradient, so you're just gonna take this part here to calculate our length of AC in that case. So it means here there's a 90 degrees. Like I said, we have proved that it's a 90 degrees. It's a right angle that we have there. All right. So the question needs us to calculate the length of AC. Remember, the length is simply taken from our distance formula. So that's 3.41. Length of AC from our distance formula, which is going to be the square root of x2 minus x1 squared plus y2 minus y1 squared, like that. All right. So this is how you are supposed to have your formula in actual sense. So you can substitute your values from A to C. Remember what I explained. This can be your first point. This can be your second point. So you can subtract the x value. So take note this time it's x to the x. So it's x value, which is minus 5. So it's going to be the square root of the x value here. It's minus 5 minus the x value there, which is 3. All right. You square that plus the y value at the second point. At the second point, the y value is 3 minus the y value at the first point, which is a 9. So even if you interchange, you get the same answers. Even if you interchange like 3 minus 5, and you use 9 minus 3 squared, you are going to have the same answer in this case. All right, so there you can just even try to simplify one by one, or you can just use everything on your calculator. What am I trying to say? I can just simplify this part inside the calculator without the square root. All right, just this part alone to see what am I actually having from -5 -3 like this. -5 -3, it means -8. Then if I square this, it gives me 64. It gives us 64. So it's gonna be 64 plus 3 minus 9 squared. Also, I just want to see what's the value for this value, 3 minus 9 squared, which is 36. So if I add these values, what do I obtain? 64, the first one, plus 36, the second one, I obtain 100. So it means I've got the square root of 100, which is AC, will be 10 units in that case. All right, the square root of 100, which is 10. So it means AC is equal to 10 units. But like I'm saying, guys, you could have just used your calculator direct at this point to obtain your answer. If you do not want to have this stage by stage, just put your square root here, open the bracket, -5 like this, -3, close the bracket, square it, all right, plus open the bracket, 3 minus 9, that's 3, -9 like this, close the bracket, square it. So this still gives us the same answer, which is 10 units in that case. All right, so that is how we could have calculated the length of AC. We move on to the other part, 3.42, the length of CB. All right, so we've got the length of CB in that case. All right, so CB, these are the points from C to B. So it's still gonna just use the same way or the same scenario that we had before, guys, on calculating length. Remember what I talked about. All right, so I'm just gonna remove this part so that we can properly have our question done. All right, so this is what we're gonna have here, right? So we need the length of CB. Remember, this is okay, 3.42, 3.42. All right, so let's see what you're gonna have there. The length of CB is simply going to be taken again from our distance formula, just like I explained before, that this, you can simply take it from the distance formula. So you're gonna have the square root of x2 minus x1 squared. All right, so that's x2 minus x1 squared plus y2 minus y1 squared, like that. So you're gonna just substitute your values, which is the square root of, remember, we're talking about C to B, and I talked about this previously, that this will be the first point, the second point. So it's the x value, which is 1, to the x value there, which is -5. So that's 1 minus 5, like this, squared, plus y2, which is the y value there, it's -5, minus the y value at this point, which is 3, like that. Then we square it. So that's how you take it, or it can be -5 minus 1 squared. Then it can be 3 minus 5 squared. Guys, the way that you understand, put it that way, you are still going to obtain the same thing. So this is actually 2 marks there. So if I substitute this and give the answer, it's actually fine. Or like I said, you can simplify stage by stage, or you can just simplify this whole part under the square root. Without your calculator, it's going to give us a 100, and the square root of this 100 is going to give us 10 units in that case. So meaning to say, or you can just, like I said previously, verify everything direct on your calculator. Here it's gonna just have the square root of, open a bracket, that's gonna be 1 minus -5 like this. Then we square that, okay, plus then -5. So this is -5 minus 3 like this. Then we square this. So this will be a 10. So as you can see, you're obtaining the same answer, which is a 10 in that case. So this is how we're supposed to have our CD. Then the other part now, they're asking us to calculate or to determine the area of triangle ABC. 2 marks for that. All right. So the area of triangle ABC, if we are to consider this is our triangle ABC. Remember ABC. Remember, we proved that on this triangle that it's a right-angled triangle. We proved that on this item 3C, that AC is perpendicular to CB. So these two lines, they are perpendicular. AC and BC, they are perpendicular to each other. So if they are perpendicular to each other, what does it mean? It means that I can obtain the area of a triangle. Remember, the area of a right angle triangle is half base times the perpendicular height. And I calculated the sides in here from A to C. I calculated this side from A to C. This side is 10. I also calculated from C to D, from C to B, not D. Where am I getting this D? This is C to B, all right? Which is, in this case, 10 units again. So with these two sides, I can be able to calculate the area of this triangle, because I know that the area of a right angle triangle is simply what? Half base times the perpendicular height. So this is going to give us the area in that case. So that's 3.5. Our area is going to be half of the base times the perpendicular height, which is any of these can be the base, can be the perpendicular height of this given size. We're going to multiply 10 and 10 together. So that's half of 10 times 10. So this gives us our area in square units. We do not have centimeters on this diagram. We have got units. So we're just going to write as square units, all right? Representation of what? Of area. So that's half of 10 times 10, like that, which is going to give us 50. So our area is going to be 50 units squared, or 50 square units. Remember, our area can be square centimeters, square meters, square millimeters, and so on. So the moment you talk about area, it must be in square units. That is what I'm trying to explain on this one. So as you can see, guys, yeah, that's it. 14 marks for that. But as you can see, this was actually a nice question. It led us to reveal a lot of things, talking about the perpendicular concept, and also to know that you now have a right angle triangle. So you can use that right angle triangle. Even they can even ask you a ratio from there. They go back to trigonometry, but that one, it is going to be advanced questions for your grade 11 and grade 12 there. All right, let us see on question number 4. BHSP is a rhombus. So remember this, you're given the properties of a rhombus. Remember, the opposite sides, in fact, all of the sides, they're equal, just like for a square. But these two sides, they will be opposite. But the sides, all of them, they are of the same length. That is from B to H, from H to S, from S to P, from B to P. All right, but these two, they will be parallel to each other, and also these ones, they will be parallel to each other. So you're given these diagonals, whose diagonals, they intersect at point A. Remember from our properties of a rhombus, that the diagonals of a rhombus, they do not just intersect. No, they don't just intersect. They intersect at a special point at 90 degrees. These diagonals, they intersect at 90 degrees, meaning to say the angle that is formed where the diagonals intersect is going to be of 90 degrees. All right. And we are given the length of BA, which is half of the diagonal from B to A, it's 8. So it means from A to S, it is going to be 8 centimeters. Remember, also the diagonals, these ones, they bisect each other. So if I'm given from A to P, that is 6, I'm also given from A to H, because the diagonals, they bisect each other. All right, then we are given the line drawn. AC is drawn parallel, this one AC, and it's taken from the center line to the other line. So what it means is that this AC is a half of the whole of BP from our midpoint theorem, because it is taken from the center. So it means this AC is a half of the line BP, that is from our midpoint theorem. All right, so guys, as you can see, we can just talk about the diagram before we even answer our questions. All right, let us answer our questions though, because someone might be, okay, what is it that we're doing? What is the question? I don't even know the question. All right, the question is there. Write down the size of the angle BAP. All right, BAP, that is BAP. We have already talked about this. Remember, from the properties of a rhombus, I said these diagonals, they intersect at what? They bisect each other, and it is going to be a perpendicular bisector, which is at what? At 90 degrees. So that means the angle inside here is a 90 degrees, which is a right angle, a right angle, a right angle. All right. So after that, the question now is calculate the size of the length BP from B to P. All right, so you can take advantage of that. This is now a right angled triangle, this one, because the angle that we have here is 90 degrees. So you are now having a right angled triangle when it is like that. And how can you calculate the length of BP if this is 90 degrees and you've got 8 centimeters here? Here you've got 6 centimeters. This is our B, this is our P, this is our A, and we want to calculate BP. We can use our Pythagoras theorem because this is the hypotenuse. All right, so there we can apply our Pythagoras theorem on question 4.2. All right, so that's from 4.2. Remember, C squared is equal to A squared plus B squared. That is the hypotenuse squared, which is the hypotenuse is the one that is facing 90 degrees, and that's our BP. So that means BP squared is equal to A squared plus B squared. These are the two shorter sides that we are given. That is going to be 8 squared plus 6 squared. So that means I'm going to have BP squared being 8 squared, which is 64, 8 times 8, 6 squared, which is 6 times 6, which is 36. And if we add this, you get 100. So that's BP squared. So remember, we need to determine BP, remove the square by introducing the square root both sides. We are going to remain with BP. Remember, guys, we talked about the square root of 100 from the last question. We got what? 10. So these are centimeters, not just units. So just here, we're going to have centimeters. So BP was going to be 10 centimeters from our calculation. There we applied our Pythagoras. All right, so that's the application of the Pythagoras theorem. So it means if this is 10, this is 10, this everything, like, because this is a rhombus, all sides of the same length. This is also be 10 here. All right, this is gonna be 10, and it's gonna be 10, and so on, like all the sides that we have. All right, write down the length of AC. All right, write down the length. Okay, please just write down. It's not like calculate actually, just write down the length of AC. All right, I talked about AC. I said AC is half of BP from the midpoint concept or from the midpoint theorem that we had. So meaning to say 4.3, you can just write this 4.3 here, just runs 4.3. All right, so if it is like that, therefore it means AC is gonna be half of BP. We calculated BP from our last calculation. BP was 10. So half of 10, half times 10, which is 5. So it's gonna be 5 centimeters. So from A to C here is gonna be 5 centimeters in that case. All right, so this is what you're supposed to have. And 4.4, determine the area of the quadrilateral BHSP, which is the area of a rhombus in this case. All right, how do you calculate the area of a rhombus? There are so many ways that you can do this to calculate our area, guys. There are so many ways. I'm just going to explain one or two so that you'll be able to be with me in the calculation of the area. The calculation of the area can simply be taken from the product after product of the diagonals for a rhombus. All right, remember the diagonals, they bisect each other. So the area can be simply be taken as the half product of diagonals, half product of the diagonal. That's it, of the diagonal, just like that. So if it is the case, we have to find the diagonals as they are because we need the product of them. So remember from our diagonals, I said they bisect each other. So if this is 8, there is an 8. So you're supposed to add 8 plus 8 in that case, which is going to give us a 16 centimeters. So now we have 16 times the product, means you are multiplying, times the other diagonal is 6 here, it's 6 here. So you're going to have 12. All right. So that'll be a 12. So this gives us the area. Okay. So like I said, I'm going to explain another way, which is the one that most of us always use. All right. So that is going to be half of product of these two. That is half of 16 times 12, like that, which is going to give us 96. So this is area, 96 square centimeters. Okay. Or like I said, because it's area, guys, it's area, and you can play around with the shape the way that you understand. here I now know that this is a right angle triangle, this and that, and we can see that there's something common that we can see here on our triangle of, on this rhombus here. So you just want to calculate another way. You must get the same 96, right? So you must get the same 96 that we got. So what I'm simply trying to say is that we can set some properties like this triangle that we see here, because we've got everything. We talked about this. It is the same as this triangle that we see here. It is the same as this triangle. It is the same as this triangle. So meaning to say that I can calculate area of one triangle, then I multiply it by 4 because it is the same as this, it is the same as this, it is the same as this triangle. So meaning to say, at the end, we could have calculated our area as 4 times the area of triangle, the area of one triangle, 4 times area of triangle ABP or APB, whatever way that you want, APB like this. So you're going to calculate the area of triangle APB, then we multiply by 4 because they are the same triangles. They've got the same units. If this is 6, this is 8. Remember, guys, I filled there. I said 8. I was having 6. So you see, it's the same triangle throughout that you are having in the first place. So meaning to say, we are going to need that area of what? Of triangle APB. How do you calculate the area of this triangle? We did not calculate this area before, so we are going to calculate it. So we're going to use, it's a right angle triangle. Remember I said here there's 90 degrees. So we're going to use half the product of the base and the perpendicular height, which is half PH. So that is half of the base. You can just take n of the values as long they are perpendicular to each other, as long they are at 90 degrees. So it can be 6, it can be 8. So you can multiply these two so long. All right, so that is you're gonna have half of the half of 8 and 6. All right, so let us see what is gonna be the product in this case. That is half 1/2 to the to 8 and to 6 again. This is going to give us 24. So we've got 24 square centimeters. This is not the area of everything. This is only the area of each triangle. Like here, there is 24 square centimeters. Here, there is 24 square centimeters. Here, there is 24. Here, there is 24. So what will be the total area? It's either you are going to add all of these areas that you are given, 4 of them, or you multiply by 4 since it's the same. So this is what I was explaining to say our area is therefore going to be the product of the what? Of 4 to the area of triangle 1 that you're given. So it's 4 times 24, and this is going to give us 96 square centimeters. So this is now therefore our final answer for the area, which is the area of what? Of the shape that we are given, which is the area of the whole rhombus that we are given in that case. All right, so as you can see, guys, that was our question having 11 marks and a total of 50 in everything. So now, like I explained from the previous class, that I'm answering these questions not for you to just answer this question, but for you to understand this topic as well, so that if you are given another question familiar to this, you'll be able to answer, because it's not like you're going to have a repetition of the same question that you're seeing now, but it helps you as you are revising so that you now have the concept. So that's why we are having this presentation. So just try by all means to understand and work with more question papers as you are revising towards your examinations. But for now, that's it, guys. Till we meet again.